Hello, chemistry students. Welcome back. We've been working on our unit on matter, and today we're going to move into our next topic, which is the properties of matter. So I'm going to share my screen with you, and we'll get started. And so today we're looking at the properties of matter, and our objective is for you to be able to classify a property or change as chemical or physical. You'll want to go back to concept 1, which talked about the classification of matter, and that'll refresh some ideas for you. But we're going to do some notes and discussion. These slides are posted for you, and as we go through vocabulary, I'll point that out as well. And there's a small assignment when we're done. So let's go back to our big idea that matter, everything in the universe is composed of atoms, and special combinations of atoms called molecules help us understand those properties of matter. So let's start looking at properties. Properties of matter are like characteristics. By observing them and measuring them, we can use them to describe the matter. And there are two types of properties: physical and chemical. So physical properties, this is a key term for you, so make sure you get this definition down. Physical properties are properties that can be observed directly or measured without changing the chemical identity of the substance. It's something we can observe or measure. And we can observe things with the naked eye. We can observe things with a microscope. We measure them by weighing them or putting a ruler on them to determine their length and volume. We can also put their volume in a measuring device. We're going to look at things like mass, volume, shape, size, color, luster, and hardness. Those are all the physical properties of matter. Some other physical properties include melting point. That's the temperature at which a solid becomes a liquid. Now, we have all of the elements on the periodic table of elements, and each one of those elements has its own melting point. Also, elements have a boiling point. That's that temperature at which a liquid becomes a gas. Now, there is a difference between melting point and boiling point. Melting point is when that solid starts to become a liquid, and the boiling point is when that liquid has reached such a high temperature that it starts to become a gas. Another physical property is something known as viscosity, and that's a fluid's resistance to flow. And this is a physical property only of liquids, and it can change with temperature. One of the more common ones that you see is honey. Honey has this resistance to flow. It's very slow. But if you warm it up, it pours out very easily. Water, on the other hand, doesn't have a lot of resistance to flow, and it flows very easily. Viscosity can be considered how thick it is. So I want you to think of a chocolate milkshake. Making a chocolate milkshake, I start off with some milk, some syrup, and then I start to add in scoops of ice cream. If I add in 1 scoop and mix it evenly, making a homogeneous mixture, it's pretty easy to drink. But if I add 2 or 3 or 4 scoops of ice cream, it gets so thick it's difficult to drink. and that's its resistance to flow. So viscosity of a syrup is high and of water is low. You can apply this principle of viscosity to the type of oil that goes in an automobile. They have that in different weights. So viscosity of a syrup, as an example, is high and of water is low. Another physical property is what is known as solubility. Solubility is a measure of how well a solute dissolves in a solvent. Now, if we talk about a solute, the solute is what is actually being dissolved. An example on that would be making lemonade. You put the lemonade powder into the water to make drinkable lemonade. The solute is the lemonade powder. A solute can also be salt or sugar or other chemicals and chemical compounds that we're going to want to dissolve. The solvent is what is doing the dissolving, and the universal solvent that we look at is water. But there are also other solvents. We use solvents to break down gooey, gummy things. We use alcohol as a solvent. We can use bleach as a solvent to break down colorants. But a universal solvent is always water. The solution is the result of combining the solute with the solvent, and that final liquid is considered the solution. For example, if we look at the lemonade, I started off with, we have this in this picture here, we start off with the pink lemonade powder and the water, and we mix it together, and it becomes a homogeneous mixture because it's evenly distributed, and we end up with nice lemonade to drink. Some other physical properties are density. And density is a measure of the compactness or the consistency of a material. And so we go back to that nice discussion, what weighs more, a pound of feathers or a pound of gold? And the density value of gold is much higher because those elements are so tightly compacted against each other. And density is measured as a mass per unit of volume. And when we get into the classroom, we'll look at how to do those measurements. We measure it in grams per centimeter cubed or in grams per milliliter of liquid. Density doesn't change regardless of size. If I take a piece of iron, the density of iron is the same whether I have a small amount of it or a huge girder that's going on a building. The density doesn't change. And we can identify different metals by knowing what its density value is. So density has a formula, and you're going to want to write this down. Density equals mass divided by the volume. That's the mass divided by the volume. Mass is measured in grams using a scale or a balance. Volume is measured in milliliters of displacement water or centimeters cubed using two different methods. Then there are some chemical properties. We've just looked at physical properties. Now let's look at chemical properties. Chemical properties are properties that can only be observed or measured by changing the chemical identity of a substance. Something has to actually change. And we do this by observing it in a new substance is formed. So, chemical properties are properties that can be observed or measured by changing the identity, and by observing it, a new substance gets formed. And what we're seeing here is an image of a Bunsen burner, which has gas flowing into it and flame coming out. And so a chemical property could be how flammable something is, or whether it's combustible, or whether it's radioactive, or whether it's toxic, because we're watching a new substance being formed. Combustibility is how easily a substance will set on fire. For example, burning charcoal when you make that barbecue. Let's go back to that a second here. So, a piece of paper is easily combustible. Gasoline is highly combustible. I remember we talked the other day about industries and how chemists help design things. Well, if you think about your house, the walls that you have are made of this gypsum board, wallboard. Now, if it was made out of wood, it would be highly flammable. But the sheetrock, that wallboard, is made up of a variety of chemical compounds that resist flammability and combustibility. So combustibility is how easily a substance will be set on fire. Reactivity is how easily a substance reacts, usually with an acid or a base. Now, for example, fluorine gas is highly reactive and will spontaneously ignite a concrete block at room temperature. Another kind of chemical property is oxidation. It's how easily a substance reacts with oxygen. We've all seen things rust, and that happens from a chemical reaction. If I take a piece of iron and leave it outside in the environment, the oxygen in the air is going to start to break down that iron, and it's called oxidation. If we add some water to it, we're now adding some oxygen in liquid form and hydrogen, and that has a reaction with the iron, and it starts to rust or tarnish. Iron will react with oxygen and moisture to create rust. There are some other physical and chemical changes, but matter can undergo both physical and chemical changes at the same time. The physical change is a change in the substance that only affects its physical properties. For example, if I have a tree and I cut the piece of wood, it doesn't change its chemical properties, it just changes its physical change. I can color something. I can take a can and crush it. I can melt ice back into water, but water is still H2O. We haven't changed its chemical property, just its physical property. We can boil water and take it out and make steam. It's still water, and when it cools back down, it'll go back to being the liquid water that you're familiar with, and as we continue to cool it, it will become ice. Chemical change is a change in a substance that affects the chemical properties, thus a chemical reaction occurs and a new substance is formed. For example, when I burn something, burning is a chemical change because let's say we take a pile of wood and make a campfire. Flame is going to happen, heat is going to come off, and what happens from as that wood is burning, we're putting carbon dioxide into the air, carbon monoxide into the air, some water vapor is going into the air, and what's left is some ash. So a chemical reaction has happened, and thus there is a chemical change. A chemical reaction is a process by which the atoms of one or more substances get rearranged to form different substances. And when we were studying biology and we were looking at photosynthesis and respiration, we went back through that concept where you inhaled oxygen and you ate food, and you put out a waste product of carbon dioxide gas, and that food broke down through digestion. And so that is where a chemical reaction occurs. It's a rearrangement of those atoms, which creates different substances. And all of this goes back to what we call the law of conservation of matter. Remember, we've talked about matter exists all over, but matter is neither created or destroyed during a chemical change. It only changes its form. And so, for example, if I'm burning some wood, if I weighed the wood before I burned it, and then after it burned, I was able to capture all of the gas and moisture that came off and capture all of the ash left, it would weigh exactly the same. So mass cannot be lost even when a chemical reaction happens. And you might be saying, but where does it go? Well, when something burns, it goes up into the air. It gets traveled along. And so fossil fuels, gasoline in your vehicle, you burn it in the engine and it puts out the exhaust, which has carbon dioxide gas, carbon monoxide, and particulate that goes up in the atmosphere. So the law of conservation of matter, and this is really important, is matter is neither created or destroyed during a chemical change, it only changes form. Now we need to have some evidence that a chemical change occurred. And there are signs that a chemical change has occurred, resulting in a chemical reaction. And they'll include these items. There could be a release of light when you strike a match. A chemical reaction occurs because you see some light. There can be a temperature change, meaning the temperature can either go up or the temperature can come down. There can be a change in the odor or the smell. There could be a sudden change of color. Gas can also be given off. And there could be the sudden appearance of a solid called a precipitate. So these are all evidences of a chemical change. Release of light, a change in temperature, a change in odor, a sudden color change, gas is given off, or the sudden appearance of a solid called a precipitate. So let's review. Chemical properties. Evidence might include the ability to burn, the ability to tarnish, the ability to rust, the ability to decompose, break down into something else, the ability to react with some other chemicals. Chemicals can be unstable or unstable. They can also have the ability to work with acids and bases in reactions. A physical change is evidence that a physical change might include a change in shape, a change in form, a change in size, a change in the phase, and that's always a physical change. Melting, becoming liquid, becoming a gas. That's a phase change, and that's always a physical change. And physical changes are usually reversible. So if I cut a piece of wood, I can combine it back together again. If I grind up metal and make metal shavings, I can remelt them down and put them back together to make that metal. Physical changes can always or usually be reversible. And the one that we see all the time that's the most reversible is our friend, the water molecule. Water can be a liquid, a gas, or a solid, depending upon what temperature it's at. All right, so we've looked at the physical and chemical changes in properties today. You have an assignment. Open up the form and complete it and submit it. You're going to identify whether something has had a physical or chemical change. You're going to identify whether something has a physical or chemical property. And then we'll get into something a little more complex, whether it has physical, chemical, or a combination of physical and chemical changes. Well, that's all we have for you today. We'll see you next time.